All right, so this is the introduction to related rates problems. If you read the problem, basically what's going on is there's this person, he's up a 13-foot ladder that's leaning against a building, and the base of the ladder is sliding out that way at 3 feet per second, so this person is falling, and the ladder is 12 feet high. So we need to do a couple things. First of all, some of you might recognize that this is a right triangle, and 5, 12, 13 right triangle is one of those right triangles. If you don't know that, or it's not one of those right triangles, you just use Pythagorean theorem to get it. All right, so the question is how fast is this number here changing? That's the question. In calculus, what we should do is give everything variables and then find the relationships. So I'm going to go with the traditional naming of a right triangle and call it A, B, and C. And so you guys know Pythagorean theorem is a squared plus b squared equals c squared. That should be a given. And then what we're going to do is name the calculus variables, or give the changes a calculus name. So instead of so we're going to think about b prime or db dt is 3 feet per second. And I want you to notice this, b is 5, and it's getting bigger, so it's actually a positive 3 feet per second. I don't need the positive, but we need to pay attention to the direction of change. Okay, so b is positive 3 feet per second. We need to think about the fact that we are looking for a prime, and we're not too sure what that is, but we should be able to deduce that a prime is less than 0, and we're going to use that as a check, because a is going to be shrinking. As this guy's falling, a is getting smaller, so a prime is going to be a negative value. And then we got to think about c prime, the derivative of c. Well, the length of the ladder is not going to change, so the derivative of the length of the ladder is going to be 0. It's best to leave it as c in the equation, just for safety's sake, and not change anything else. So the question is, now we've got this relationship between a, b, and c that's really easy, and we're going to turn it into a relationship between all the derivatives, which is a little trickier. But now that we have the equation, all we have to do is take this derivative with respect to time. And when we do that, we need to make sure we're taking the derivative implicitly. So it's going to, the derivative of a squared is 2a times the derivative of a with respect to t, which is a prime, or dA dt. And we're going to do the same thing with b. 2b times b prime equals 2c times c prime. And this is it. All we have to do now is plug in values for all of our variables. I notice that everything is multiplied by 2, so I could divide this whole thing by 2. You don't have to, but you certainly can. And now I just need to plug my values in. At the moment of time that I care about, I know that a is 12, and I don't know a prime. So I'm going to get 12 times a prime plus, and then I look down here and I know that b is 5 and b prime is 3, plus 5 times 3. And I know that c is 13, but more importantly, I know c prime is 0, so the right side of my equation is 0. Great. Now it's just a quick evaluation. This equals 15, so 12a prime plus 15 is 0. Subtract 15 and divide by 12. I get a prime is negative 15 over 12. Both of these numbers are divisible by 3, so it's negative 5 over 4. And I should get used to putting in my units, feet per second. And notice it's negative, so I've done a good job. It's negative. Notice also it's moving out slower than the bottom, and at that moment in time, that kind of makes sense. Great. We're going to try another problem similar to this. So the next problem we're going to do is, how does the area underneath this ladder change? So we know, I already forgot. That's embarrassing. Give me one moment. We know negative 5/4. We know that this is changing at negative 5/4 feet per second. So that's something that we know. We are going to find this area. You guys need to think about, well, what's our equation? Area equals base times height divided by 2 for a triangle. So we're going to call this base, we'll call this height, and we know that area equals base times height over 2. We're wondering how this area is changing. So where really means what we're trying to do is find A prime, and you might be able to intuit that A prime is going to get bigger until this becomes a 45, 45, 90 triangle, and then it'll start getting smaller. So we know that A prime should be less than 0, should be negative. I'm sorry, I said that backwards. It is getting bigger, it should be greater than 0. Okay. Let's remember we got to give everything some names. So this 3 feet per second, well, that's going to be B prime. B prime is 3 feet per second. And H prime is going to be negative 5/4. Negative 5/4 feet per second. So now we can take this derivative. But before I'm going to do that, I am going to rewrite it like this because I don't want to use quotient rule and I don't want to make that mistake. So I'm going to take this derivative with respect to time. So I'm going to get A prime equals 1/2 times, I got to follow product rule here, B prime H plus H prime B, product rule. Now I can just plug in. So I know that A prime is what I'm looking for. I've got my 1/2 here. B prime is 3, it's positive 3. H at the moment I care about is at 12 feet. 12 feet plus H prime was negative 5/4, and B is 5. So this seems like I just need to do a quick evaluation. I am going to, I don't know why, I'm going to distribute this 1/2 and turn this into 18. 36 divided by 2 is 18 plus, or I should say minus 25/8. I need to have a common denominator to do this. This is getting a little bit more than I wanted to do, but this I believe becomes 144, 64 times 6. Yeah, 144/8 minus 25/8 is going to give me 8. 119/8. 119/8. But the real question is, what are the units? And the units are feet squared per second. So that is how fast the area is changing. I'm going to do one last problem real quick. And the last problem is, how fast is this angle changing? So we got to deal with this angle. I know that this is negative 4/3, I think. Shoot, I wish I had it written down, but we're going to make pretend we don't know. It doesn't matter. What I want to do to figure this out is come up with a relationship with theta. So that means I need trig. And this is the side I know most about, and this one has a derivative of 0, so I'm going to think about what is my derivative that has that. Sine equals opposite, or cosine. I'm going to go with cosine. It doesn't really matter. Equals adjacent over hypotenuse. So I'm going to name this A. I'm going to name this H for hypotenuse. I need to know that H prime equals what? Oh, it equals 0 because of it doesn't change length. A prime is positive 3 again. I know that theta prime is just what I'm looking for. I know that that had better be less than 0 because theta is getting smaller as we fall. So now I'm just going to start taking this derivative. The derivative of cosine is negative sine theta times theta prime. That's the part most students forget about, times theta prime because of channel. And then I gotta take this derivative. I need to follow quotient rule. The derivative of the top times the bottom minus the derivative of the bottom times the top over the bottom squared. But notice that the hypotenuse derivative is 0. So this is going to be 0. That's going away. And shouldn't have the prime there anyway. And then I can cancel out this with that. So we end up getting theta prime equals a prime over h times times 1 over negative sine theta. The trick here is we got to figure out, well, what is the sine of theta? We know h is 13, so I'm just going to fill this in. I'm not going to do the math out. A prime is 3. We know that sine of theta is opposite 12 over hypotenuse 13, so this is times negative 13 over 12 is theta prime. And then we can cancel out my 13s, and I'm going to get negative 1/4. And the trick is this is radians per second. It's always in calculus, we go with radians per second. Anyway, that was a quick 3 different types of problems. Good luck with the practice.